Assalamualaikum and good morning everyone. Today we are going to cover for topic 2 about indices. First, we must know why we learn about this chapter. Why? Because it's mostly used in the fields of science, engineering, accounting, finance, astronomy, computer, and so on. So who want to be engineer? Maybe you want to be astronomer. You maybe want to be accountant. You must know how you work with indices. What is indices? Indices are useful way of more simple expressing large number. Indices ni adalah salah satu cara macam mana kita nak meringkaskan nombor yang sangat besar. For example, here we have 9,765,625. It's a very large number, right? Okay, actually this large number we can write in index form. So the answer here we have 5 to the power of 10. Okay, 5 to the power of 10 sebenarnya sama dengan 9765625. Cuba you tekan calculator. Dapat sama kan? Alright, indices. We go basic for indices. You must know. Let's say here we have 3 to the power of 4 is read as 3 to the power of 4. Yeah. How to read this number? You can read 3 to the power of 4. The way how to read correctly. Where you must know 3 we call as base, 4 we call as index. Okay, here we have index form show in repeated multiplication. Okay, I think this one you have learned when you were in form 1, right? So actually this here 2 to the power of 3 equal to, that's mean 2 multiply by itself for 3 times. Okay, for example here how we show it in repeated multiplication, we can write 2 times 2 times 2 times 2 times 2 times 2. How many 2? 6 times. So here we can write the answer in index form 2.5 to the power of 3. And for this one we also can show in repeated multiplication 7 times 7 times 7 times 7 for 8 times. Teacher rasa you dah tahu kan 7 to the power of 8, that means 7 multiplied by itself for 8 times. Same also with this one. Okay, repeated multiplication, yeah, same also for just now, like just now 6 to the power of 3, that means 6 multiplied by itself for 3 times. Also we same with for the second example 2 to the power of 5, that means 2 times 2 for 5 times. Okay, for the third example we have negative g to the power of 4, that means negative g multiplied by itself for 4 times. Okay, So here, repeated multiplication, we can write in index form 9 to the power of 3, because 9 multiplied by itself for 3 times. Okay, for the second one, we have 1, 2, 3, 4, 5. The answer is 25 to the power of 5. Okay, this one we have how many times? 4. Then we put in bracket negative kg to the power of 4. Okay, same also for this one. We can write, put in bracket 6w to the power of 3. Now we proceed expressing a certain number in the index notation. Maknanya kita nak tulis sesuatu nombor itu dalam bentuk index notation. For example here, we have expressed 32 in the index notation with base 2. Okay, macam mana kita nak nyatakan 32 dalam index notation with base 2? Dia dah bagi dah base berapa yang dia nak, base 2. So how to come out the answer? We do repeated division. This one we call as repeated division. Masa form 1 you ada belajar ni repeated division, tapi waktu tu you belajar masa form 1 how you want to find LCM HCF. Okay, for this one, how you do repeated division? You just here you bahagi sahaja dengan 2, sebab dia kata dia nak base 2. Dekat sini buatlah dulu dia punya rangka tulang ni. Jadi 32 bahagi 2 dapat 16. 16 over 2 you get 8. 8 over 2 you get 4. 4 over 2 you get 2. 2 over 2 you get 1. Okay, this process you stop when the last number you get 1. You stop when you get the last number is 1. So the answer here we can write the answer. How many 2 here? 1, 2, 3, 4, 5. The answer in index form is 2 to the power of 5. That means 32 we can express in index notation is 2 to the power of 5. Kalau you nak check, you boleh tekan calculator. Betul ke tidak? Betul ya? For example tu, same also, we do repeated division. 625 and then dia dah bagi dah base 5, bahagi dengan 5 je semua. You do the process until you get the last number is 1. Okay, 625 625 over 5 you get 125. Then you continue over 5 you get 25. 25 over 5 you get 5. 5 bahagi over 5 you get 1. Then you stop here. The answer is 5. 1, 2, 3, 4. The answer is 5 to the power of 4. Okay, express exercise session. Express each the following in the index notation with the base given in the bracket. Okay, yang ni teacher nak you buat repeated division, show how you get the answer. Okay, multiplication of numbers in index notation. Okay, usually actually we can we can manually get the answer by doing like this one. 3 to the power of 2, that's mean 3 times 3. For 2 times, continue times 3 to the power of 3, that's mean we continue 3 multiplied by itself for 3 times. So the total here we have 5 times. The answer we get 3 to the power of 5. Same also for this one. 9 to the power of 3, that's mean we can write 9 times 9 times 9 times 9. Then proceed with multiply with 9 to the power of 4. 9 times 9 times 9 times 9. Then how many 9s here? We have 7 times. So the answer here we have 9 to the power of 7. Alright. Here, here I want to tell you, actually this one is the first law. First law in indices. Take note. This one is first law. A to the power of m multiply a to the power of n equal a to the power of m plus n. Law ini hanya boleh digunakan dan jawapan dia macam ni when the base number same. Kalau base number dia sama, we can simplify a to the power of m plus n. Power dia kena tambah. Contohnya kat sini. Macam tadi kita kira secara manual. Dan kalau tengok, kalau kita nak listing dia sangat panjang kan. Okey. Tapi kalau kita guna law ni, working kita hanya pendek. Dan untuk indices memang kita kena apply law lah. Untuk topik indices, we can do multiply, but it's very long. But here indices you must use the law in indices. Okay, so here kalau kita tengok sini base, okay, for example number 1, kalau kita tengok base number dia 5, ni pun 5 kan. So sini adalah base number dia same. Then operation here we have times, multiply. Okay, so how you get the answer for this question? You can use this law. So equal to 5 to the power of 4 plus 5. Then here we simplify, we get 9. So here we have final answer 5 to the power of 9. Okay, same also for algebraic. Okay, base algebraic. This one we call algebraic, right? Okay, hash. Okay, multiply. Okay, hash, same base. Then we can use this first law. We get hash to the power of 11 plus 18 equal hash to the power of 29. Okay, we proceed for multiplication of numbers or algebraic terms with the same base. Okay, kalau you tengok kat sini, multiplication of number or algebraic term. Okay, number ni maksudnya kat sini lah. Kalau you perasan tadi kita melibatkan base number sahaja kan, tapi kat sini kita depan base ni kita ada number. Okay, macam mana kita nak dapatkan jawapan dia? Okay, the way correctly is, okay, nombor dengan nombor maknanya you hipun satu kali. Okay, 3 times 2. Okay, you put in bracket 3 times 2. Okay, then Okay, base number. This one adalah base number. This one index, right? Okay, you tengok index. Index dekat sini, indices dekat sini, base dia sama. Operasi dia darab. You boleh guna the first law tadi. Okay, kalau sama, let's mean A to the power of 2 plus 3. Okay, here we get 3 times 2, we get 6. A to the power of 5. Okay, boleh? Sama juga dengan for the number for number 2, number 3, number 4. Okay, number 2, same also. You put in bracket for the number 6 times 2, you get 12. This one you can apply the first law. We have F 5 plus 3. Then the answer is 12. F to the power of X. Okay. Alright, we proceed for simplify multiplication of numbers or algebraic term with different base. Okay, dekat sini kita pelibatan pendaraban nombor dengan algebraic term base yang berbeza. Okay, kalau you perasan example for number 1, kita ada base 3, kita ada base 2. This one base 3, we have base 2. Okay, kat sini base dia tidak sama. Jadi the way how you get the answer, you kumpulkan base yang sama. Untuk dapatkan jawapan macam ni, sebenarnya dia comes from macam mana teacher kata nak kena kumpul. Okay, sekarang ni kumpul dulu. Base 3 to the power of 2 times 3 to the power of 4. Okay, yang ni sama dengan ni. Okay, dah. So tinggal lagi yang ni kan. Okay, darab times 2 to the power of 3 times 2 to the power of 7. Okay, so the answer here, we can use the first law tadi. Okay, then we get 3 to the power of 2 plus 4 multiply. Okay, this one also we can use first law. 2, 3 plus 7. Then here we have 3 to the power of 6 times 2 to the power of 10. Okay, ni jawapan final answer. Kalau different base, you tidak boleh simplify ataupun you calculate the answer using calculator. Dia tidak akan dapat jawapan dia satu nombor. Tidak. The final answer macam ni lah. Dia walaupun nampak dia macam tak lengkap, tapi sebab case dia different base, jawapan final answer dia macam ni lah. Sebab kita tidak boleh permudahkan. Okay. Sama juga kalau kita melibatkan algebraic term. Algebraic term pun sama, the way kita samakan, kita himpunkan algebraic yang sama. Lepas tu baru kita guna law. Kalau sini sebab kita guna law pertama tadi, sebab kat sini operasi darab. Okay, sama juga macam mana dapat ni. You can do like this one first. K to the power of 5 times K to the power of 8 times M to the power of 6 times M to the power of 7. Then this one we can use the first law. K 5 plus 8 times M 6 plus 7. The final answer K 13 times M 30. Okay. For the number 3, you can try. Alright, now we proceed for division of numbers in index notation. Okay. The first law, we involving multiplication, but this one is second law. Second law in indices. Base number dia sama, tapi sekarang operasi dia bahagi. Kalau bahagi base sama, same base, we can simplify A to the power of M minus N. Okay, for example number 1, okay, operation division, same base, then we can simplify, we use the second law. The answer we get 5 to the power of 7 minus 5. Then we get 5 to the power of 2. Same also for algebraic term, same base. Then we just subtract the power, 21 minus 18. The answer is hash to the power of 3. Okay, so here example, I give you answer for the number 1. This one, same base, operation division, we can simplify 3 to the power of 5 minus 3. Then the answer 3 to the power of 2. Okay, K 14 minus 5, we get K 9. Okay, same also for this one. You try, okay? Raising numbers and algebraic terms in index notation. Alright, this is a second law in indices. Okay, raising number and algebraic term. Okay, contohnya dekat sini the third law. Okay, this one is index form, right? A to the power of M, then tutup bracket, dekat luar ni pun ada lagi power. So here we can simplify, equal A to the power of M times N. Macam mana dapat ni? M darab dengan N. Mn ni operasinya sebenarnya M times N. Teacher rasa you all tahu kan? Okay, kalau yang ni contoh kat sini, tengok ni index form, dekat luar ada power lagi. So we can simplify 5 to the power of 7 times 5 equal to 5 to the power of 35. Same also for the algebraic term. Power we multiply both, we get 160. Okay, for the third example here, okay, kalau tadi dia melibatkan index form sahaja, tapi kalau yang ni dalam bracket ni dia ada nombor. Jadi macam mana nak kira dia? Okay, dekat sini you kena tahu konsep everything. Kalau dalam bracket dia ada power kat luar, maknanya setiap benda yang ada dalam bracket ni you kena power 5. So sebenarnya kat sini you akan dapat, okay, maknanya 2 pun dia kena kuasa 5. Kalau base number ni maknanya C 7 darab 5. Okay, dapatlah 2 to the power of 5 C to the power of 35. Okay, kalau tengok contoh yang dia bagi 1 times 5. Dari mana dapat 1 times 5? Sebenarnya you tahu kan? You tahu tak? Kalau 2 ni bermaknanya 2 kuasa 1. So dekat sini kalau yang macam new learner, maksudnya baru nak tahu sebenarnya, sebenarnya this one adalah 2 to the power of 1 times 5. Tapi sebab teacher ni dah biasa dengan ni, teacher terus direct 2 to the power of 5 C 7 darab dengan 5. Okay, okay, sekarang ni kita tengok pula yang ni. Nombor ni dia dalam index form kan? Yang ni memang dalam index form lah. Okay, kat sini yang ni memang 1 kan? 1 base dia, power dia 1. Kat sini power dia 2. Jadi macam mana nak open the bracket? Racing tu maknanya kita nak pecahkan bracket tu. Jadi 3, 2 darab dengan 8 hash 8 darab dengan 8. Dia satu persatu. Kita guna law yang ketiga tadi. So the answer kita dapat 3 to the power of 16 hash to the power of 64. Okay. Computation involving negative index. Kalau bercakap tentang negative index, maknanya index kita mesti negatif. Okay. Maknanya dekat sini, you tengok ni index form. Negative index form. Kita boleh tukar dia dalam keadaan fraction. Negatif ni dia dah jadi, kalau kat sini dah dalam fraction, dia jadi positif. This is for law in indices. You must know that a to the power of negative n equal to 1 over a to the power of n. Daripada negatif, bila kita tukar kepada fraction, we produce fraction, n ni dah jadi positif. Okay, so here we have example. Kalau nak tukar dia dalam fraction, macam ni lah. The answer 1 over 8 to the power of 7. Sama juga dengan ni, algebraic. Yang ni, tukar kepada fraction, we have the example. We have the answer 1 over f to the power of 2. Okay. Perform computation involving negative number. Sekarang ni kalau melibatkan negative index, maksudnya operasi darab, bahagi. Okay, macam mana nak buat ni? This one adalah negative index, right? But dekat sini, dia punya ni penlibatan dia darab. Sama juga. Kalau darab, base number dia sama, kita guna law pertama tadi. Law pertama. So, we get the answer 2 to the power of negative 2 plus put in bracket negative 4. Sebab apa? Sebab kita kena, kalau macam mana you tulis working, kalau plus, lepas tu you kena tambah dengan negative number, biasanya kita put in bracket lah. So here we get, okay, plus negative, you akan dapat negatif. You belajar ni masa form 1. Positif jadi positif. Negatif jadi negatif. Negatif jadi positif. Positif negatif dapat negatif. Okay. So dekat sini dia apply. Jadi tambah tolak jadi tolak. The answer negative 2 minus 4. You get negative 6. The final answer 2 to the power of negative 6. Yang ni kena master Siapa yang tak master lagi ni? Teacher rasa masa topik 1 tu direction number ke? Tak ingat dah teacher topik apa. Tapi ada you belajar ni. Okay, sekarang ni operasi bahagi. Kalau bahagi, tengok kat sini. Base number dia sama, maknanya kita boleh guna law yang kedua kan? Law kedua. Jadi power dia kena tolak. Negative 5 minus. Kenapa minus? Sebab bahagi, lepas tu base number dia sama. Tolak lagi 2. Tolak jadi apa? Tambah. Sebab tu lah dapat ni. Jadi negative 5 tambah 2, dapatlah negative 3. Okay? Okay, sama juga dengan ni. Ni index form. Okay, ni pun melibatkan negative index. Tapi dekat luar pun ada negatif lagi. Ni kita guna law yang keberapa tadi? Law ketiga. Jadi darab sahaja. Kita nak pecah bracket ni. Jadi negative 2 times, put in bracket negative 4. Jadi negative 2 times negative 4, we get positive 8. Okay, involving fractional index. This one, kalau tengok index dia dalam fractional. Okay, fractional index kita boleh letak jawapan dia dalam roots notation. This one kita panggil, kita boleh convert dia kepada roots notation. Okay, you must know that kalau macam mana kita nak tukar dia, senang je. Kalau M ni, kalau A to the power of M over N, M tu adalah power, N tu adalah roots. Okay, macam mana kita nak tukar ni? M ni adalah power. And ni adalah roots. Okay, cuba kita tengok example here. Let's say daripada sini fractional index ni kita nak tukar kepada roots notation. Ingat lagi tak? Ni kita punya dia punya jawapan dalam roots notation. This one mesti power, this one kena roots. Okay, kalau tengok sini 1 ni adalah power, 4 ni adalah roots. Okay, the answer dalam roots notation, fourth root, kita panggil fourth root lah. Fourth root 8, tutup bracket, power dia kat sini lah. Power dia berapa? 1. Okay. Okay, kalau yang ni 3 ni adalah power, 4 ni adalah roots. So how we change in roots notation? Macam ni lah. The fourth root F, close bracket, power dia adalah 3 kat sini sebab power dia kat sini 3. Okay. Ni adalah jawapan untuk how you want to change the root notation. Boleh cuba and compare the answer. Okay, so here kita macam mana nak calculate value using calculator. Using calculator ni senang saja. Mula-mula you tukar dulu kepada roots notation. Lepas tu baru you tekan calculator. Macam mana ni? Okay, dekat sini usually kalau square root 2 ni kita tidak tu don't write. Sebab kita dah tahu dah kalau macam ni bermakna dia adalah square root. Kalau dia third root, baru kita letak 3. Kalau fourth root baru letak 4. Kalau 5 root, letaklah 5. Kalau 6 root, kalau 2 usually we don't put lah. Sebab kita dah tahu dah kalau tak ada nombor kat sini dia adalah square root. So macam mana nak tekan calculator ni? Press ni, tengok ni. Ni adalah cara-cara lah. Cuba you tekan button yang ada ni, square root 81. Lepas tu yang ni kalau boleh kan kita open dulu bracket. Yang ada bracket tu open. Lepas tu baru put dia punya square root, letak 81, tutup bracket. Lepas tu tekan button yang ada power ni. This one yang ada V terbalik ni sebenarnya adalah bermaksud power. Okay, berapa? 1. So tekan equal. Dapatlah berapa jawapan dia? 9. Sama juga ni. You boleh try using the calculator. Change roots notation first, then you using calculator. Sebenarnya tu macam mana kita guna calculator. Ada juga cara. Sebenarnya kalau calculate the value, sebenarnya kita tidak boleh tunjuk bahawa kita guna calculator. Kita kena tunjuk macam mana kita dapat jawapan tu. Contohnya dekat sini kita ada 25 to the power of 1 over 2. Bermakna kalau kita tukar dalam kita panggil apa ni, roots notation. Okay, kita dapat macam ni kan. Square root 25 kita tahu sebenarnya, okay, this one square root lah. 2 ni usually we don't write 2 here, like I talk just now. So this one power, this one power, this one root kan. Okay, ni lah form dalam roots notation. Then sebenarnya square root 25 kita dapat berapa? 5. So power kat sini adalah 1. 5 kuasa 1 dapat berapa? 5. Okay. Calculator itu just how you want to check your answer. Is it correct or not? Tapi kalau untuk indices ni, you memang kena tunjuk jalan kira how you get the answer. Okay, for this one sama juga, you tukar dalam roots notation. Then we know that kalau you dah biasa dengan base number, apa base number, apa panggil, square root, third root, apa, square number, apa ya. Lepas tu you tahulah kalau 3 darab 3 berapa? 9. Kalau 3 darab 3 darab 3 berapa? 27. Sebenarnya benda ni lah puncanya. Punca 3 ni 27 dapatlah 3. So you kena banyak biasa dengan indices lah ni. Dia punya square root, square root lah masa you belajar masa form 1 kan. Okay, so here we get 3 to the power of 1, you get 3. Sama juga dengan ni, fifth root, sebab sini power, ni roots. Okay, so we change in roots notation, you get fifth root 32. Yang ni bolehlah you tekan calculator, sebab kalau you memang tak biasa, you dapat 2. Okay, 2 power dia 1. Ya, walaupun awak guna calculator, tapi jangan tunjuk. Tapi jangan kita macam direct dapat final answer. Kita kena tunjuk jalan kira how you get to. Jadi dari sini dapatlah 2 to the power of 1 dapat 2. Sama juga dengan ni. Okay, so for indices, actually we have 4 laws in indices yang sangat penting. Dan teacher harap you boleh buat, dan you faham. Make sure faham, make sure ingat law-law yang ada dalam indices, kat mana nak apply. Okay, itu sahaja daripada teacher. That's all for today. Thank you.